everyone. We're going to express each complex number in polar form and give angle measures to the nearest degree when necessary. So before we get started, here is your diagram, and we know that A from our previous videos equals r cosine of theta. It's your horizontal line. B equals r sine of theta. So this point here is AB. Now Z equals AB, which equals your polar coordinate r theta. And r equals the absolute value of Z. So basically Z, which is r, equals the square root of a squared plus b squared. Now, this is non-negative, so r is going to always be positive, and that's going to affect sometimes our angles because you're looking at the length of this arrow here. So looking at the length, you always want to do positive. All right, so we'll get started with some examples, these 4 examples. So the first one, we want to express this in polar form. So what you're going to do is you're going to take, in our case, our A is -1 and our B is 1. So R equals absolute value of -1 plus I, which equals the square root of -1 squared plus 1 squared, which equals the square root of 2. And it's already positive. So that's going to be square root of 2. And to get your angle, we just do tan or inverse tan of y over x. So this is just going to be 1 divided by -1, which equals -45. Now you notice -45 is in the 4th quadrant, but our r is positive here. So what you want to do is take your angle. This is your angle. And you're going to take 180 degrees minus 45 degrees. And that's going to give you 135 degrees. So that's 135 degrees. And the way IB wants you to write it is square root of 2 cis 135 degrees. And for the first time, this is just going to be square root of 2 cosine of 135 plus I square root of 2 sine of 135 degrees. That's just the shorthand way of writing this. So IB wants you to write it this way. All right, then we go a little faster now. So in this case, this is like 0 minus 3i. So to get r, we're just going to take absolute value of -3i, which equals the square root of 0 plus -3 squared, which just equals 3. And if you look at the graph here, sometimes it's easier. -3i or 0 minus 3i is 1, 2, 3 on the imaginary axis. This is your imaginary and this is your real. So right away you can see what your angle is. Your angle is 270 degrees. So you don't have to do the tan function. So your final answer is going to be 3 cis 270 degrees. All right, next one, we have this. So we're going to find r is absolute value of 1 plus I square root of 3, because we want the positive arrow. That's going to be square root of 1 squared plus square root of 3 squared, which equals 2. So do your inverse tan function or arctan. That's going to be square root of 3 divided by 1. And that equals 60 degrees is your angle. So when you write it out, you're just going to write this as your R. So it's 2 cis 60 degrees. And finally, the last one, we have R equals absolute value of negative 2 minus 2i, which equals negative 2 squared plus negative 2 squared, which equals square root of 8, which equals 2 square root of 2. All right, and then you're just taking inverse tan of negative 2 divided by negative 2, and that equals 45 degrees. So since we're in quadrant, both are negative, this is quadrant 3, we're going to have to readjust this because our R has to be positive. So for R to be positive, because of the arrow has to be positive, we have to get this 45 degrees angle into quadrant 3. So what you're going to do is you're just going to take 180 plus 45 degrees, and that's going to give you 225 degrees. You have to always remember where you're at. So this is going to be 2, then you just put the 225 degrees here. And then you'd write this as 2 square root of 2 cis 225 degrees. And that's it. Thank you. Have a nice day. Bye-bye.